In this last series of word problems, we're going to look at situations that involve shapes again, but they're going to be slightly more complicated shapes. And building our equation is going to be the challenging part. Once we get to the equation, the math is going to stay the same, so make it equal to 0, standard form, and either factor it or use the formula. Okay. Because these are sort of a complicated shape, my suggestion is we should try drawing a diagram whenever possible. And we've got just some examples today. So we have a rectangular sheet of tin, 15 centimeters long and 9 centimeters wide. So if we draw that, get ourselves a rectangle here. Okay, we know it's 15 centimeters long. Oops, get rid of that, sorry. 15 centimeters long, and it's 9 centimeters wide. A uniform strip. Now that's a key word. The word uniform means the same size. And what we're going to do is we're going to cut the uniform strip off around the sheet. So we're going to cut off a piece from this side, and a piece from this side, and a piece from this side, and a piece from this side. And it's all going to be the same width. Okay. And the remaining area is to be 112 centimeters. So we know the part that's left over, and this part in here, is 112 centimeters. We want to calculate the width of the strip to be cut off. We don't know what that width is, but we know it's the same. So I'm going to call this width, the distance from here to here, x, which would make this x, and it would, because it's uniform, make this x, and make this x. So what I used to have was a rectangle that was 15 centimeters long, right? This was 15. But I've cut off x from this piece and x from this piece. So now I have one that's 15 minus 2x. It used to be 9 centimeters wide, but again, we cut off this piece here that was x, this piece here that was x. So now we have 9 minus 2x. And these two dimensions we just figured out here and here are actually dimensions of our sheet. And we know that the area is 112. So we can make ourselves an equation. Area is length times width. Our area is 112. Our length, or width, is 9 minus 2x. The other one's 15 minus 2x. The order you put those in is not important. Length and width are sort of interchangeable depending on your point of view. Okay, I got myself an equation. We need to solve this. In order to solve things, they have to be equal to 0 in standard form. So I'm going to start off by FOILing on the right side. 9 times 15 is 135, minus 18x, minus 30x, plus 4x squared. And notice I put the 0 in because I'm going to bring the 112 over. So minus 112 at the end. Okay, I'm going to put in the right order. So 4x squared minus 48x's and plus 23. So now I've got equal to 0. I've got in standard form. It's ready to be solved. I look at this and I see a complex trinomial. And we know with complex trinomials, it's probably just as fast to use the quadratic formula. So we'll do the opposite of b. Remember b here, plus or minus the square root of b squared minus 4 times a times c, that's our discriminant, all over 2a's. Well, the first thing we need to do is check if this can be solved. Let's calculate that discriminant. Underneath the root sign, I got 1,936. It's positive, so yes, I can get answers. What are the answers? Well, we should have two of them, right? 11.5 should be the first one, and 0.5 should be the second one. Now, with these shape problems, we're always going to come across two answers, and one of them is going to be inadmissible, something you can't do. Sometimes it's obvious, a negative length or a negative width. But in this case, it's not so obvious because they're both positives. So I have to go back to the problem and think about what I'm doing. X is the width of the strip to be cut off. So if I look at the first number, and this number is 11.5, and I try taking 15 and subtracting 2 11.5s, well, I end up with a negative. I end up with negative 8. I can't have a length that's negative 8 centimeters. That's not possible. So this first answer is inadmissible. I'm cutting off too much to actually have a rectangle anymore, which means this one has to be the answer. Okay? The width of the strip is 0.5 centimeters. Now, if I were to try that back in the original question, that tells me that, I'll get rid of this inadmissible one here, and we know that doesn't work, but it tells me that this piece is 14, And if I do the same thing with this one is 8. And if I try 14 times 8, yep, I get 112 centimeters squared. So that's my right answer. Okay, let's try the next one. A square lawn is surrounded by a walk. Oh, I got a square lawn. Okay, let's start with a square. So that's my lawn. It's surrounded by a walk, 1 meters wide, which means if I put a walk around it, it should all be the same. It should be uniform, right? I didn't line that up quite right, so I'll try that again. Yeah, that looks better. Okay, so I've got myself a lawn. That's the part in the middle. We'll color it green, right? There's my lawn, okay? And the walk is 1 meter wide. So cement all the way around it. That's one, that's one, that's one, and that's one. What else do we know? The area of the lawn, so the lawn, is equal to the area of the walk. Okay, that's good to know. And find the length of the side of the lawn to the nearest tenth of a meter. So, what do I know about the lawn? The lawn's this part in between here in the middle, right? But I don't really know how long it is. I don't know that. Nor do I know this. But I know it's a square. So if I call the horizontal length x and the vertical length x, that could be the area of my square, right? In other words, x times x, or x squared. So that means the walk itself is also x squared. Now the way we're going to try and approach this problem is, if I know this inside part is x squared, and I know this outside part is also in between here, x squared, because they're the same size, how do I find the area of the whole thing? Well, the area of the whole thing is made up of this dimension, which was x plus 1 plus 1, or in other words, x plus 2. That's a square, so we can do the same thing on this side, right? X and 1, or x plus 2. Well, the area of the whole thing, so rectangle or square, the total area is length times width. Now, what's the total area? Well, it's made up of the inside shape, the lawn, plus the walk. So in other words, x squared plus x squared. And the dimensions, the length of the lawn, the whole thing, sorry, are x plus 2 and x plus 2. Well, that kind of looks like a quadratic that needs to be solved. I can do this by foiling, rearranging, and notice I collected these two things and made them to 4x, okay, and making it equal 0. I have to do one more little small collection thing here. And now I have myself a quadratic in standard form equal to 0. So I can solve that. I can't, it looks like man, but there's nothing that multiplies to negative 4 and also adds to negative 4. So man's not going to work. I need to use the formula. So the opposite of b, plus or minus, let's find our discriminant, b squared minus 4 times a times c, all over 2a's, will give me 4 plus or minus discriminant. 16 plus 16 is 32, and it's positive, so I can actually solve this. And you get two answers. My first answer is negative. Oh, negative. I can't have negatives because that's the length of something. There's an inadmissible answer right off the bat. Because remember, we're looking for the length of the lawn. Or I get positive. That must be the right answer. 4.83. 828 actually. Well, there's my answer. The lawn is 4.83 meters wide and long. It's a square, right? So it's both. Because for this question, it was a little bit trickier in that we had the x's on the inside this time. We had to build ourselves an equation by figuring out the things we knew, the dimensions of the whole thing. We're going to try another one of those. I'm going to give you guys to try this one. So pause it, see if you can figure this one out yourself. A landscaper has decided to build a uniform walkway around a rectangular garden. Okay, I got a garden. Oh, that's not a garden, that's a square. Yeah, rectangle. Rectangular garden. We're going to put a walkway around it. Okay, so I need a walkway and it's uniform, so it should be the same. That looks pretty good. We know it was 18 by 12. The area of the garden walk, okay, we don't know how big it is, but we know it's uniform. So X and X and X and X, which makes the whole thing an X and 18, another X, in other words, 18 plus 2 X's, and width-wise, 12 plus 2 X's. Same idea, right? It has been decided that it would look best if the area of the walkway, so the walkway, was equal to the garden. Equals the garden. Well, how big is the garden? We know that. It's 12 by 18. In other words, 216 meters squared, which means they're both 216, right? Okay, so our total area equals length times width. Our total area, the walkway and the garden put together, we have a 216 and another 216, has to equal the dimensions of 12 by 2x and 18 plus 2x. There's my quadratic, ready to go. We just got to solve it. So 516, oh, no, 516, 532 equals 12 times 18 is 216 plus 24x plus 36x plus 4x squared. We want to make this a quadratic equal to 0, so 4x squared plus 60x plus 216 minus the 532. Or in other words, 4x squared, 60x, and minus 216. Okay, ready to go. Standard form equal to 0. Let's try factoring, because this one looks like it's all divisible by 4. Might as well do that first. Make it simpler, if anything. And 54. Looks like a simple trinomial. Multiply to negative 54. Add to 15. Ah, there are numbers that do this one. 18 and negative 3. So x plus 18, x minus 3. Those aren't my answers, my factors. My answers, my solutions, are negative 18 and 3. Well, we can't have negative lengths. That's got to be an inadmissible one. So the walkway must be 3 meters wide. And we're done. That's our third set of word problems. We have ones that already have equations, ones that we had to build simple equations for. It could be a money problem, could be a simple shape problem, and we have these slightly more complicated ones with pictures we have to decide on. The homework is in the sheet that you got yesterday, the last set, or sorry, second set of word problems. Give them a try. Answers on the website. Take a look at them. If you're stuck, come see me.